Hello, let's look at worksheet number 2 for our review. This probably will seem a little bit easier than the worksheet that we did yesterday. And I think you'll be fine on the first page. I have posted my answers, and you can certainly look at those to see what work I did to get my answers. Number 7, maybe 7 is a little bit unique, so I'll run through 7, but I really want to get to 11. So from 7 to 11, let's look there. A portion of the function f is given in the figure to the right. Let g of x equal f of 3x squared plus 4. Find g prime of 1. First thing I'm going to do is just get the general derivative by applying the chain rule. So I'm going to take the derivative of the outer with it, which is my f function, leave the inside evaluation alone, and now chain off and take the derivative of the inside piece. So I'm going to chain off and get 6x because the derivative of 4 would be 0. Next, I'm going to evaluate this at 1. So I want f prime of 3 times 1 squared plus 4, and then a 6 times 1. That makes this f prime of 3 plus 4, or f prime of 7, multiplied by 6. F prime of 7, getting over here to 7, f prime indicates the slope. That's a down 1 over 2. So it looks like we have a negative 1/2 slope times 6, getting me to a negative 3. G prime of 1 is negative 3. Number 8, 9, and 10, I hope these look somewhat familiar. You will have a couple of these on the test, and by now you should be identifying that this is asking for a derivative. How do I know that? Well, it's a limit process for one. Second, if I let x go to 3 and I put 3 in here, that is going to drive the denominator to 0, and that is a good indication that we want to find the derivative. This particular derivative is getting evaluated at 3 because I look at the pattern f of x minus f of c over x minus c, limit as x drives towards c, is the definition of f prime of c. So what I must do is I must take the derivative of f. This was nice. They defined f for us. So the derivative of natural log I know is u prime over u, or 1 over x. Now, last step was to evaluate this at some particular location, which is 3. I can tell that by looking right up here. And that's going to make this 1/3. Yeah, not bad problems once you catch the hang of it. Limit as h goes to 0. Okay, that's going to take and drive the denominator to 0. What is my function? Well, the function is natural log x. And I know that because I know the pattern used in this particular layout is f of x plus h minus f of x over h. So my eyes immediately went to the end sequence where f of x is. I also noticed there's that x plus h. So natural log x must be our function. Then we just need f prime of x, and the derivative of natural log is 1 over x. Easy. Got it. This was just a general derivative for number 9, so I don't need to do more. How I'm going through these, I guess I'll just go ahead and do 10. So this one, driving towards 0, this is that same pattern of f of x plus h minus f of x. So I think what I'm going to do is, it's standing all by itself. This is what f of x is, isn't it? F of x equals the secant of 5x. Now I just need to take the derivative of that, and the derivative of secant is secant times tangent, and then take the derivative of that inner function, which is a 5, so I get f prime of x equals 5, secant 5x times tangent 5x, done. All right. Oops, I went too far. Sorry. Let's look at 11. 11, given the curve, and I notice first thing is x and y's are intermixed, this is probably going to be an implicit differentiation. So show that dy dx is equal to negative 2x plus y over x minus 3. They kind of gave you the answer, didn't they? We should be able to match up to that. And in order to get full credit, you have to match exactly to what they have. So we will work on our algebra to make that happen. Here we go. All right, I'm going to start out by taking derivative x squared is 2x, running into the product rule, derivative of x is 1 times y plus x dy dx, because I had to take the derivative of y, minus 3 dy dx, and the derivative of 3 on the right is 0. I want to keep the dy dx stuff on the left, so I'm going to go x minus 3 dy dx, factoring out dy dx, sliding these two terms over to the right will give me a negative 2x minus y. Using division, I'm going to get dy dx is equal to negative 2x minus y over x minus 3. I feel good about that answer. So I look back up here and I'm like, wait a minute, it's not an identical match. And by identical, we mean exactly the same. And what I noticed is on top, they had factored out that negative. So I will do the same. Now does it match up? You betcha. So we've got our derivative. Part B, write the equation of the line tangent to the curve at the point 2, 1. This is ideal because they gave us the ordered pair. I don't have to go find y or find x, so that's lovely. What I do need for an equation of a tangent line, well, I have the point. I need the slope. And the slope's going to come from the derivative. So dy dx, and you know what? I'm going to input that point, so I'm going to show evaluated. You can do that. That's expected that you do that each and every time. I think I'm getting my x and y's mixed up. A 2 and a 1 over a 2 minus 3. So on top I got 4, 5. Negative 5 over a negative 1. I'm coming out with a slope of 5. Hope you did too. Now let's write the equation of the tangent line. That's the easy peasy part. Y minus 1 equals slope x minus x sub 1. There's our answer. Y minus 1, 5 minus x minus 5 times x minus 2. Find the x coordinate of the point where the line tangent to the curve is horizontal. To become a horizontal tangent line, I know that it has a derivative that must be 0. So I'm going to take negative, what was that? Negative 2x plus y over x minus 3 and set it equal to 0. Well, the only way that that's going to equal 0 is if the numerator equals 0, right? 0 divided by some number equals 0. Some number divided by 0 is undefined. If you had to find a vertical tangent line, this would be your, let the denominator equal 0. That'd be your game. But we want numerator set to 0. So let's just take our numerator, pluck it off, negative 2x plus y, set it equal to 0. Divide by negative, it's gone. Subtract, I think I'll make y equals. Subtracting 2x gets me a relationship here that says y is equal to negative 2 times x. Darn it, I didn't get my x values. I have two variables. In order to solve this, I must use another equation. Guess which equation we're going to go back to? We're going to resort back to the original equation. Yes, you may have to do something like this on the test, particularly the May 8th AP test, and more short-term, the Unit 3 test. Don't be surprised if you have to do that. Okay, so I'm going to substitute this into the original equation. Okay, into original equation. So I'm going to replace y's. When I encounter y, I'm going to stop and replace it. I encountered a y, because x times y, this will become negative 2x then. Minus 3, I encountered a y, replacing it with negative 2x, set it equal to 3. What just happened? A miracle! Well, what happened is we got down to x's, and that's a beautiful thing, isn't it? So we get x squared minus 2x squared plus 6x equals 3. Okay, I'm getting a little panicked, but I'm going to just keep plotting through. If it's quadratic, I know I could try factoring, which doesn't look very fruitful on this. I pulled that negative. And I think this is one where it is not factorable. So then I guess I'm into A equals 1, B equals -6, and C equals 3. Trust me when I say the AP, I've never seen them do this before, but it is in our arsenal of tricks that we should know. That's quadratic formula. So x equals -b plus or minus square root b squared minus 4 times a times, my head's in my way of seeing this, times 3. All over 2a. Okay, we got it. See, just thinking helps, doesn't it? 6 plus or minus square root 36 minus 12 over a 2. X equals 6 plus or minus square root 24 over a 2. Keep on simplifying. X equals 6 plus or minus, that's a 4 times 6. That's a 2 root 6 over a 2. Everybody has a 2. Everybody's going to get reduced by 2, so that's going to be a 3 plus or minus root 6. Take it out of there, not out of the 6. And this went to a 1. There's my x values, as pretty and lovely as they are. All right. Lastly, it says let's take a second derivative. This will be some work. And I would say this is pretty standard for an AP problem, is to take a quotient rule and have you complete a second derivative. So, which is part of the reason why in part A, they give you the answer and just say, show me how to get that first derivative. By giving you the first derivative, they've assured you that you can proceed with problem D and get the right answer. So let's get a second derivative. This is quotient rule, isn't it? Second derivative. Know your nomenclature. So how do I want to deal with this? I honestly would rather have my negative. You know what? Would it be okay with you if I move that negative to the bottom and then make it look like 2x plus y over negative x positive 3, so 3 minus x. I'm going to work from this version because I think it'll make a cleaner derivative for me than having that negative hang out front. That bothered me. And what we did is fine. Okay, so derivative of the top is a 2 plus a dy dx multiplied by the bottom. Subtract in quotient rule. Derivative of the bottom is going to be a -1 multiplied by the top, 2x plus y, over the bottom squared, which was 3 minus x quantity squared. Now, typically you cannot leave your answer with dy dx in it when I'm trying to find second derivative. So let's do that replacement. We know how this works. D squared y over dx squared will be 2 plus, I'm just going to go ahead and use this version because it will look prettier than having that negative hang out front again. So I replaced dy dx, looks like that was wrapped in parentheses, times a 3 minus x. Negative negative makes positive, 2x plus y. You can put it in parentheses if you want, but they aren't necessary there, over a 3 minus x quantity squared. This is fine. You can just leave your answer there. If you would like the challenge of doing the algebra and getting to the final answer, you can play around. The answer I got was 2x plus 2y plus a 6 over 3 minus x quantity squared. Okay, so if you want that extra challenge of taking this and working your way down, go for it. My work is shown on Schoology if you want to see how I achieve that. But just know for the test tomorrow and for the AP on free response, this is all you'd have to do. This would be fine. All right, good day.